Good evening. I want to welcome you to tonight's lecture. A couple of housekeeping items before we start. Firstly, you might put your mobile phones on silent. Secondly, fire exits. You see there the doors which you came in, and also the door at the back. Now, also, I understand that last week at the lecture, a few people at the back had some difficulty hearing. So, can you hear me at the back clearly? Now, if there is an issue, you might just let us know, and our technical expert here, Ronan, will sort all the problems. Now, before we introduce tonight's speaker, just to set out our program for the next few weeks. Next Friday night, the 8th, we have our annual dinner at the Maryborough House Hotel. There's still some places available, and colleague John Lapdorn over there will speak with you if you have any queries. Next Tuesday night, 12th, we have a lecture on flood risk management by Barry O'Connor of MacDonald. Tuesday the 26th, we have Introduction to Acoustics and Noise Reduction. And then starting on Saturday the 2nd of March, we have Engineers Week with the usual activities during that week. Now, tonight's lecture, as you can see, the topic is Panelised and Modular Offsite Construction. The speaker is James Young, who's a chartered engineer. He's a graduate of Cork Institute of Technology, Structural Engineering. I understand he's going to give a slightly longer CV at the start of his presentation, so I won't dwell any further, other than to say he's working with Evolution Innovation, who are specialists in off-site construction. So, James.
Good evening. Thanks very much for the invitation today. So, as said, they're here to talk about panelised and modular off-site construction, just to give a flavour for what's possible, what's been done. Yeah, so just a brief history of myself. Graduated in CIT 2006. From 2006 to 2009, I joined Fusion Building Systems, who were operational in Ringaskiddy at the time, and that they were, I suppose, they were pioneering light gauge steel panelised construction at the time. And then, unfortunately, after 2009, when the slowdown hit, I emigrated for a number of years, and I suppose I made use of my time. I spent a year in Momentum Builder, setting up a modular factory there. Spent a couple of years in mainstream structural engineering with another company, and happily in 2013 returned back to Ireland and have been with Evolution ever since. Got chartered in 2014, and in 2015, for those of you that might do some work in the UK, NHBC is like the equivalent of Home Bond, and they have a system where there's a chapter in it that specialises in light steel frame, and I'm recognised to act as a third-party certifier in that instance. So the objective of the presentation today is just to provide a brief history of off-site construction in Ireland, outline technical aspects associated with panelised off-site systems, the same for modular, show a few case studies, and then I'll show what is the potential for modular construction in Ireland at the end. So, why Evolution Innovation? We believe we are market leaders in kind of independent turnkey off-site consultancy in Ireland and the UK. To date, since 2010, we've worked on off-site projects to a value in excess of €2 billion. Proven track record in various off-site projects in housing. We've also, in recent times, been advising some of the best-known construction industry leaders in off-site construction and where the market is going. And we also have some nationally and internationally recognised staff. For example, our CEO, Declan Wallace, for example, has been part of a working group for Part E in the past. So one of our missions, not only to act as a consultancy, but it's also to promote off-site generally, especially in Ireland. as it's becoming more and more popular and recognizable. So, and then to make sure that, you know, that it is built to the highest quality, surpasses all building regulation requirements and standards. So currently, just a brief overview of evolution. Our head office is in Cork. We have about 40 staff now. We also have offices in Dublin and in London. We've 5 core departments. Some of the 3 that I won't be delving into involve quality, building physics, and quantity surveying. But the 2 that I will be kind of referring to this evening involves the department that I lead, the structural engineering department, which basically specialises in structural engineering of offsite systems, particularly panelised and modular systems, as well as your traditional construction. And also on the product development side, which we'll talk about later in relation to fire, acoustics, and other aspects of that. Also, just to mention that we're currently preparing to make our application to Engineers Ireland become a CPD accredited employer, which we are delighted with as being a relatively young company to be going in that process. So for today, right, and this is with the greatest respect, what I'm here to talk about is, when I say offsite, is not the following. What I'm here to talk about is high quality housing, mid-rise residential student accommodation or hotels, or the high-rise, which we'll talk about later on. Now, to some of you, offsite, especially when it comes to the likes of modular, it might appear that this is just a recent entry into the construction sector, but that's not the case. For example, when I was working with Fusion Building Systems, here's an example of a 3-story residential building that we did in Cork, 2007, concrete with all load-bearing light gauge steel panels with concrete floors. So there was many more examples of that in the country. And then there was also some examples on the modular side. So this was in the early days of Vision Modular, the residential development done in Dublin when they were operational out of Ringaskiddy. So there are various offsite systems in Ireland. Always, you know, timber frame, SIPs, you've light gauge steel frame, you've precast concrete, and you've panelised ICF systems, and you've lightweight modular systems, you've hot rolled steel modular systems with concrete slab, and you've now even innovative foundation systems like passive foundation solutions. So there's more and more products coming to the market all the time. So the 3 that I'm going to concentrate on this evening are light gauge steel frame and both lightweight and hot rolled steel modular systems with concrete. So light gauge steel, also known as cold form steel, light steel framing, light gauge steel framing, and load bearing SFS, known in many. One of the advantages of light gauge steel, it has a high strength to weight ratio, does not shrink or creep. It has flexibility in that it can be designed with lightweight steel floor joists and also with concrete composite deck floor options. It can also accommodate hot rolled steel beams and columns to deal with any to deal with the transfer of heavy loads, where you might have non-tracking poles or might have cantilever balconies or whatever is built into the system. So it can be very versatile. The lightweight system can reduce the dead weight loading when built from a transfer slab by up to 40% and even up to 25% with the use of concrete decks. It can accommodate multi-level concrete slabs, and currently we have systems certified up to 10 stories or 30 meters available in Ireland. So from a structural design point of view, up to quite recently, we would have used BS 5950 Part 5. So obviously we've now moved on to Eurocode. So the current Eurocode is EC3 Part 1, Part 3, and we also use Part 5 and 8 when we're designing light gauge steel structures. It's worth noting that now the new Eurocode design results in approximately 15 to 20% additional steel for the same building, especially in the walls. It's reassuring to see from a design perspective, but obviously not so good from the manufacturer's point of view. And one of the main reasons for that is that was the old combination check in British standards. Now in the Eurocode, we have a combination check that has to the power of 0.8, which results in the increase in your unity factor. So previously, where you might have been at 0.9 here, you're now finding that potentially you're failing. So it's evolved into a more conservative design. And obviously, that code covers other elements like stud and floor joist capacity, global stability, and disproportionate collapse for the structural design of the structure. Another useful document if you're looking at this system is light steel framing. So the SEI Steel Construction Institute is a body in the UK that specialises in a lot of this offsite technical advisory notes, and this is document P402, which generally goes through how like steel is compliant in all parts of the building regulations, and it is very applicable to the Irish construction sector. Currently, as of today, we have one company that's NSCI certified up to 10 stories. But you will find that on the right-hand side, there are 3 following very soon. I think you'll see Horizon Offsite is one that's going to come live very, very soon. Also 10 stories. So obviously very important in relation to Part D, the building regs, for systems need to be NSCI certified. So these are the ones that we're aware of that are in process at the moment. Interesting one with Carlo Concrete, keep an eye out for it, taking a very unique twist with the light gauge steel, where they're actually looking to create a true wall solution, where in time they're looking to kind of pour a wall with a precast external wall and tie the steel frame to it and deliver that as a full true wall solution when it gets to site. So that's something a bit different, but something that's very, very applicable. Just kind of broadly, just from a manufacturing point of view, typically a lot of these manufacturers, they get in the flat steel coil, like you see there, various gauges. The steel gauges that we designed there, typically S350 to S550. That's very high strength steel, and it's sent through a roll former. This is a Howick roll former. There are many other roll formers out there. So it goes through the roll former based on the NC code that would have gone through design, which we'll get to in a moment, and it goes on to create all the various sections that we need. So typically for walls, you would have studs ranging from 70 mil to 150 mil with various gauges. And then you have various companies that do deep sea sections for the floor joists that can roll up to 450 mil thick. And then you have other systems that create floor trusses using the studs from this section. So I'll show you some examples of that later on. So typically, panelized walls that would come out, you see all your studs generally that would come out of the roll former. So in the factory, all that wall would have been prefabricated in the factory. Studs generally at 600 centers. You can have flat strap bracing, others use K bracing within the walls. And all systems do things slightly differently. Like this system, the external walls come insulated. Some of them will have wall-tie channels on it. And that whole wall, it can be 3 meters tall. The length of it is based on logistics more often than not than design. And it's the same process whether it's a 2-story house or a 10-story building. So that's generally how that comes together. So from a structural point of view, what does a general light gauge steel manufacturer provide? So this is just a typical hotel. So what they would do is they can provide you all the external walls as load bearing that can arrive panelized, insulated, and with other ancillary items such as wall-tie channels, like I mentioned. You can also get your lift shaft cores and your stair cores. They can all be built within the system. The internal walls, load bearing, generally would be just non-load bearing partition, but we would use this as part of the structure. They would all be provided as part of the system as made as load bearing. and then finally integrated hot rolled steel as required, where the building might step back, for example, or you might have some, a lot of glazing along the external facade, for example. So that's, all of that is all provided by a light gauge steel supplier. And one of the main things to note is the core is taken out of the critical path, because we're not looking at tracing all the stability back to the cores. All the walls are used within themselves as mini shear walls, so it takes the cores out of the critical path and can be formed as part of the build as it goes up. And that's why, it can have really quick construction times. Just to extract some of the details, so this is just a sample of one of our manufacturing models. So typically, if we were to look at typical foundation detail, so that's a typical foundation detail, where it's for a house or for a high-rise building. And what you see here is you have your steel frame with the bottom track that sits down on top of the DPC. They come with the insulation on the outside of it. Some provide, some don't. You can have your, as I mentioned, your wall tie channels as part of it. So when the masonry is going up, just very simply slot in the wall ties into that. It can also arrive with elements to support cladding or brick slip or other elements like that. And it's all designed around, the thermal aspect and the structural aspect of the foundation. Then just to go typically further up the building, if you were to look at a typical floor, so again, your studs at 600 centers, and as I said, we use a concrete deck. So typically, what you can see here is that that's the top track of a load bearing external wall. Typically, you have a concrete deck that ranges between 140 to 170 mil, and what the systems typically use is composite deck suppliers. So we don't use it for the composite action. What we use it is for the permanent formwork and for the minimizing of propping in work. So that's showing that decking running parallel to that particular wall, but typically you can span onto the walls and continuously as required. And then on the lightweight floor options, again, that's just an extract of a BIM model, but typically some systems out there will provide deep sea sections such as that, typically 250 in depth, and others provide trusses which are created out of the same sections that you have in the walls. So both equally is good, and typically for a lightweight floor, you would have your Z sitting on top of your load bearing wall, and that would sit straight on top of that and screw fix into the wall and align with the studs in behind it. Again, that's typically for, again, 2-story houses or up to 10 stories. The same philosophy applies. So in relation to case studies, I suppose one thing in relation to the recent case studies that I have, most of what I'm showing are manufactured by Irish-based companies. But most of what I am showing is based in the UK. There is a lot in the Irish pipeline that I cannot show currently due to commercial sensitivity, but there's some very impressive projects coming down the line in Ireland. But this will just give you a flavour for what we've been designing recently ourselves in Evolution. So just starting off, this is University of Sussex down the south of England. It's a £150 million student development. Phase 1 included 26 blocks, so ranging from all of these here and all of these and across the top there. In this case, foundation design was by principal engineers, which were ARP in this case, and we've provided the structural design for the superstructure on top. So all panelised light gauge steel load bearing elements with a lightweight floor option. And as I'll get to later on, a lot of the design that we do is very BIM led. So a typical process that we would be following is, that's one of the blocks in this particular development. That's the Revit model that we would have gotten off the architects. We would have gone ahead and done our own offsite BIM model. So everything we see here is specific to the system that we're working with, all showing all the load bearing walls, the floor joist directions, integrated hot rolled steel were required. In this case, there was a fin wall here. openings and so on. So that's the model done in Revit that we would use for all our projects where we clash detection, the architect, M&E, and so on. This typically then leads on to a manufacturing drawing. So I know that looks a bit messy there, but what you can see is this is the model that gets created, that creates the files, that gets fed into the roll former, which we referred to earlier. So what you can just about see is for the same building, your studs, and what you probably can see is you have your lightweight steel joist running in there as well, all the integrated hot rolled steel and so on. And then that obviously transforms into what you get then on site. Just some other examples of recent. So that's currently going through the first phase, ranging from 5 and 6 stories down to 3 stories student blocks on that particular one. Another development that we've worked on recently is a job again in Norfolk. It's a 440 apartment development. Blocks ranging from 3 stories to 8 stories. So again, the podium design was done by others, but the superstructure sitting on top was designed by ourselves. So again, going through the same process, all the blocks ranging in there. So these blocks, just to go through the process. Get an architectural Revit model from the architect. So that's an 8-story building, the tallest building on this particular site. Has everything from high-rise masonry, external clad, so we have to integrate relieving angles at upper levels, cantilever balconies, high-rise penthouses, and we take that from the architect, go through, do our structural design and our BIM pre-construction model, create the model that we use for the clash detection and coordination with the design team. Again, it has everything in it, and then that leads on to, as I say, the model that goes just before we go into manufacture. So this will give, just from a structural perspective, just to get a bit more clarity. Studs generally at 6 from the center, so all the walls we see there, they're all load bearing. In this case, 90 mm wide stud sections, lightweight floor joist spanning within the building. So we don't see the series of party walls and internal walls running inset into the building, acting as part of the lateral stability. All those walls are braced up, as you can see there. And you can also notice elements like the lintels over the openings that are all built into the panels. So again, those panels come in all various widths and lengths, and the same, if required, the floors as well can be cassetted and delivered on site, and it all just depends on site logistics. So again, just another view of that, and that's just one of the recent photos. So that's nearing completion there at the moment. So again, there's another one of our ones that we're kind of proud of there recently. Obviously, we do a lot of hotels. So again, this is a typical model extracted from a software called Vertex. Vertex is a specialist software. Does light gauge steel. It also does timber. It specializes in producing the code for the roll formers. But again, what you can see there's your traditional podium. And again, you can see your studs, all aligning, our X bracing, our openings, our lintels, and in this case, our lightweight floor trusses spanning in that direction. And you get to see the final product. Again, numerous premier ins and so on that we've completed in the past. Just some other ones. There's an 8-story residential building that we've done, finished last year. Again, 8 stories. This one is had concrete decks all the way on top. Yeah, and from a commercial aspect, we were able to reduce the depth of the podium, even by using concrete decks on this, by the use of the lightweight nature of the system. But this had many challenges in it. It had cantilever balconies over here, and you know, lift shaft cores, precast stairs, and as I said, concrete decking at each floor level. So again, that's the model before I went into manufacture. Again, same philosophy applies. Your studs are lining up. What you don't see are all the load-bearing walls within the building, and then you see all the concrete decks at each floor. And when you get into the specifics, you get into specifics of global stability and disproportionate collapse, you get into the detailed design of the slabs to make sure that you're compliant, in this case, the 2B classification. Again, that's just the finished example of that quite recently. Again, just another 8-story hotel that we would have done. Brick slip finish. I suppose what made this particular hotel a bit interesting, we had a 4-story masonry facade over 100 years old that we had to restrain, temporary restrain in both the permanent and temporary condition, which we were able to do. So again, the system was able to apply itself to be able to adapt to accommodate that. And finally, kind of one of the higher ones that we've done recently is a 10-story student accommodation block that we've just finished off at the end of last year, for currently being finished out. So it has light gauge steel, lightweight floors. So again, that's another one of our one of the tallest buildings we've done recently. And at the moment, 10 years ago, or even 15 years ago, it would have been, the system would have been looked at from a 2 or 3-story, but there are companies out there that are taking this to the next level that it's able for. I suppose kind of close to home, just wanted to, I suppose, on the social housing side, we've been doing a lot of work with ABM quite recently. We've done over, I think it's well over 100 units at the moment. So with DCC, we're currently on our 3rd lot of housing. So, being able to, in this case, the ground floor, 1st floor, and the roof trusses were provided in light gauge steel, and that's worked really well. And I think there's more in the pipeline from that point of view as well. So, just jumping on to modular systems, again, just also known as volumetric, also known as pods. Again, just concentrating on the Irish market. As of today, I'm sure many of you have seen Modern Homes Ireland in the media quite recently. They currently have a 3-story certified system and soon to be published 10-story system. And you also have Extra Space, who have a system certified up to 4 stories. And at the moment, there's more and more of these systems coming online. Again, there's plenty of systems out there, but just on who's certified, that's who we have as of today. So in relation to, from a structural standpoint, I'm going to concentrate on 2 elements. You have the uniformly loaded modular structure, and you generally have the corner supported modular structure. So the first one, which is the uniformly loaded modular structure, which is generally the one that at the moment MHI would apply, which is very similar in nature to the panelised system that we just spoke about. But what they do is they take those walls and they tie them together on site. And at the moment, for their housing in Ireland, and they only supply Ireland at the moment, typically the ground floor module goes out floorless, and then the 1st floor module goes out with a floor and the ceiling in it. So there's a certain bit of sacrifice in terms of trying to optimize. But as you can see, this is before it's even insulated, putting in the doors, lintels, and this is all tied together on the base, ready for transport. So again, these guys have invested a lot in a lot of equipment and a unique transport facility on site, and even taking things to the next level. They have clients that are looking for solutions, and they are providing solutions such as that, a prefabricated modular roof truss that they supply. Again, these are all houses that they've recently completed in Ireland, mostly high-end houses, all traditional brick finishes. These are duplexes that they finished during the year last year in Navan, I think. And again, you can see the the level of finish, from a perception point of view, the quality of finish. So obviously, excluding the furniture, but a lot of that pitch roof would have been made in the factory and would have come with the floor in that shape. That's how it would have arrived to site, plasterboarded and painted and so on. On the cornice supported side of things, we have, this is a school we would have done with Extra Space a number of years ago in London. It's a 4-story school, and the cornice supported system here that they apply is one that a lot of companies use currently in Ireland. So this school, just taking it as a case study, was 4 stories. And it integrated a 2-story PE hall as well. So again, from a design perspective, this isn't the actual school, but what the cornice support module allows a lot of versatility in terms of applying to any architectural layout. Yes, it'd be great if all the layouts perfectly stacked, but that doesn't necessarily stop modular systems being applicable. So you can see all various odd shapes as required. Some systems will supply a room and a corridor, so as it's installed, you get instant access. Some of them will include the stairs as part of the module. But again, the cornice supported, you're able to be versatile where you track your columns and locate it. So it's very flexible in relation to the architectural layouts, can accommodate various scenarios. Different philosophies can be taken from a stability point of view. You can have, in this case, one that tracks back to the core, or you can have a bracing system that's kind of distributed in consistently across the building in both directions. So again, this is an extract from the technical model that we would have coordinated with. So for typical cornice supported module, the corner columns are typically hot rolled steel sections, and the ground floor beams and the roof beams would be cold form sections typically. They can be hot rolled, again depends on the design. And then your floor joists and your roof joists are typically cold form joists, typically to the ones I outlined previously. So again, they're all dropped in, coordinated in relation to the design. In this case, we had the bracing, which would be hidden within the infill walls that would be that are not shown there. Again, you have the bracing going in both directions, integrating stairs into it as well. So from a design perspective, just taking that disproportionate collapse, that's the general philosophy that we can take when it comes to modular buildings. There's 2 different scenarios. So in the case where this module is removed from supporting above, we look from a 2A or 2B classification as tying these modules back to the main structure here, and so on and so forth. And again, quite simply, if this was to go, all these modules are typically so interconnected that it is usually not that difficult to achieve the required tying elements that you need in a 2A or 2B classification. So you can adapt that generally to that. Again, in this case, that's the hot rolled steel 2-story PE hall that we have to wrap around. So again, using BIM, they're your corner supported modules wrapping around and all tied back to the hall. So in this case, we'd use the hall as part of our lateral stability element. But again, the core supported element was able to be adopted for this 4-story school. So the system has no issue being part of a hybrid solution, and is interconnected and is able to offer stability to the modules. And again, where that comes in from the manufacturer's point of view, if we can utilize this, it means less bracing, which means it makes it more efficient to make these systems in the factory. And again, that's just the work in progress there. And just again, from a finishes point of view, typical PE hall, and there's the school. Nothing to do, like when they say that the modular construction impeded on the finish of that school there. Another job that we would have done about 4 years ago now. If you're standing from Wilton, you look across the CUH, you will notice this building. So when before the paediatric unit was being built, we built this. Well, it was called a decant building, but obviously it's going to stay there for a while. So the paediatric moved into this part of the building to allow for the construction of the new permanent paediatric unit out the back. So we would have acted as designers on this, providing. It was a single-story extension onto a live hospital, the live outpatient hospital that you see out there. And the process was that there was a hot rolled steel grillage that we had to design, which acted as a podium for the loaded that was loaded at designated locations. So the client's representative was Arab, so we worked with, and they basically indicated where we could load onto the existing structure below. So we created a hot rolled steel grillage, and then we designed a modular. It was actually a hybrid of modules around the outside for all the rooms, and then centrally for all the various stations and so on was the panelised light gauge steel, and that's what we did there. All the modules on this were all installed over a weekend. So once all the prep work was done over a weekend, I think up to 40 modules was installed over the course of 2 days. So again, just a work in progress drawing. Again, this is something that's kind of an element that's becoming very popular with the likes of the light gauge and the modular systems is upper story extensions. You know, doing a lot of it in London, and it's starting to happen a lot now in Dublin, especially hotels extending up and certain buildings looking to extend up from a residential point of view as well. But again, the reason this was chosen because of the relative lightweight nature that we're able to justify by loading onto an existing 40-year-old building. So again, there's the grillage that we would have designed. There's one of the modules going in, and in the background you see the panel of light gauge steel. So it'll all be tied in together. And again, from a perception point of view, you know, this is all part of the modules. So modules were able to cater for ramps, steps, and so on. So, you know, one of the main points to take away from today, you know, we don't, you know, ideally we'd like architectural layouts that are perfect boxes, but that's not necessarily the case. Whether it's panelised or modular, they can be very much more flexible than you think in terms of meeting the architectural intent. So, other design considerations that we would be involved in, I suppose. So to start off, we all know aware of NZEB. It's a part that we're very, very heavily involved with. We've NSAI registered thermal modelers who are kind of working a lot in this space. So, you know, NZEB is bringing a significant improvement in a relatively short space of time. So this is a graph that we've put together. So kind of when BER first came into play to today, we're now looking at a 70% improvement from what we had a number of years ago. And to be honest, a lot of these years were lost. So, you know, you could argue it's a jump from almost here to here. That is going to add significant cost to a lot of our buildings going forward. So one of the things that we specialize in, we specialize in thermal modeling, especially in relation to offsite systems. So as I said, we have NSAI and BBA registered thermal modelers, and we specialize in Part L compliance of offsite systems, looking at obtaining the optimum psi and y values. So again, what we're looking at there is one of our typical panelised, that's a twin party wall junction detail. That's an external wall junction detail, and that's, I think, is an external wall coming into the ceiling of a roof, where you can see there are studs in there. So this is something that we're very heavily involved in, and one of the things that we're promoting when it comes to designing, because of NZ and costs, is taking kind of like a fabric first approach, where almost before you go almost near the structural design, that you look at what is going to be the energy strategy of the building, and how are we going to get an NZ compliant building, and what do we need to do, and how much is it going to cost. So that's something that we're, as I say, very heavily involved in. Again, just some other buildings, just a continuation on just from kind of Part L compliance. Other aspects that were kind of, so we'll talk about this building later on, but dynamic simulation modeling, something that we work on as well. From a fire perspective, this is something that we, again, we've been very, very busy with over the last few years. So we project manage fire tests, load-bearing wall tests, typically for any system really, and we do it for floors. So loaded floor test, the EN1365. Our team are using fire test halls in England, Northern Ireland, done one in France, and I think we've been looking at one in Holland as well. So that's a typical example of one of the ones that we would have done. So I think last year alone we would have done project managed 35 loaded wall tests, and I think I don't think anyone else would have done more than that. Again, on the floors, we would project managed for various clients, loaded floor tests to EN1365 Part 2. Again, there's the system set up, there are the loads on top, and typically whether it's for a 30, 60, 90 minute, and this, I suppose, obviously a lot of this data which gets fed into the NSEI sorts of the various systems, but allows us then in terms of to review the specification for the various buildings that we're designing. You then have your BSA 414 tests, so you can't see that, but what I was saying there is, for tests for buildings over 18 meters, if your system isn't an A2 classification, you must have a BSA 414 test. So obviously due to recent events, this is something that a lot of work is going on with at the moment. Other elements we do, from the acoustic point of view, there can be perceptions out there from acoustic standpoint when it comes to offsite systems. But we've done a lot of lab tests. We've had a lot of post-site completion tests. So when it comes to specifying wall build-ups for airborne through walls, whether it's a twin party wall or a single frame wall, we know the right specification that's required for the various systems by virtue of lab testing and post-completion testing. And again, with the floors, whether it's impact or airborne, we have a lot of experience in knowing what needs to be specified to be Part E compliant. And generally, it's our policy to design offsite products for residential that can achieve a minimum of 5 dB better than the building regulations during post-completion testing, because the last thing you want is that issue on site. Other kind of aspects from the testing is the CWCD standard testing for systemized building envelopes. Where basically what you have here is a jet engine that's applying pressure onto this. This is a constructed cladded element for a client, and that's checking everything from air permeability, wind resistance, water penetration, and so on, and also includes some static and dynamic testing as well, like what we have there. So we've project managed, and we believe we've project managed and witnessed more fire tests than anyone in Ireland and the UK. And as I mentioned, we did 35 loaded wall tests alone last year with a 94% success rate. So, bringing a lot of experience to that, knowing what's going to work and what probably won't work. So, what I'll finish with is, is what I say is the future. So, and as I say, I was only going to say the future is now. So, This is so Vision Modular is a system that would have started many years ago as a sister company to Fusion Building Systems. They're now operational in the UK, and they are doing pioneering work over there at the moment. So this is a series of buildings that they've completed. So, as I said, the system started out as a sister company to Fusion Building Systems many years ago. They're now operational in the UK only. Many would consider that the system that these guys provide is probably the best modular system in the world. They would be one of our clients, but we don't do the structural on this. So typically, the core and the foundation is done by Bart Manny, company in Dublin and London, and then the modular work is done by Michael Hawk and Associates in Dublin, and also supported by a very strong in-house team. Obviously, many of you will probably know that they're embarking on what is probably going to be, what will be the tallest building in the world. The core is already up, and you will see that come to fruition. But again, that's what you see there is the basis of a system that was developed in Ireland. A lot of design coordination is developed for people in Ireland, and there's a lot of guys that spend a lot of time over there with a strong Irish connection. So we have the expertise are there, but it's just what they're doing in London is exceptional. Just taking one of the examples, this is a Lucium. Now, just to emphasize, these are two 11-story buildings, and you can see there just from the timelines that they're operating on, it's just out of this world. Starting RC works December 15, September 16, it's fully occupied. That's two 11-story buildings. Okay, and you can see, that's typical. There are typical modules going in. Sometimes I believe it's core supported, otherwise it might be a panelised system, depending on what they're doing. Has a concrete deck, and typically from a stability point of view, they also utilize the core. So, it's a very impressive system, and high end finishes that you get there. And just what I'm just going to finish with is just, as I say, is a video that I just have to, jump over here. So this is one of the buildings they would have completed, I believe, the year before last, 28-story building. But again, you can see, follow the timeline. Again, incredible timelines. See no scaffolding on the outside. High-end finishes. Again, on that particular one is in Mindley Way, so you'll actually see there's 2 or 3 other buildings in that area that they've also completed. So I believe at the time, a couple of years ago, this was 28 stories. I think was then the tallest modular building in Europe, I think, at that particular day. So once they have all the modules in, you have your mass climbers putting in the cladding afterwards. And again, that is 14 months of work. So I guess the point I'm making there is, that's what's possible, that is what's being done, and there's no reason why no one in Ireland can be doing that in the future. So again, thank you, thanks for allowing me to present here today. Again, that was just a brief synopsis of those particular technologies. So we'll take any questions.